to everyone. Welcome once more to another video in our YouTube channel. So in this video we focus on the topic conic sections, and we are going to be solving just a particular problem, which is Cameroon GC June 2020 for the math paper 2, specifically question 5. So before we go further, students who are preparing for the Cameroon GCE upcoming 2023 session and you offer further maths, please endeavor to note that further maths paper 2 is actually 50% of the whole of further maths in the GCE. So don't joke with paper 2, because if you have an A grade in paper 2, then definitely you have had an A grade already in further maths, because paper 1 is actually around 45% of paper 2. So paper 1 is 15% and 50% in paper 2. You can have everything there. It's very possible. So you're already at 65%. Now paper 3 as well is very direct forward. So paper 2 is always what is a little bit complicated, yes, because the topics are many. But now there are certain topics that when you master them very well, you're good to go. Alright, so in upcoming videos I'm going to lay more emphasis on how the percentages are being shared, and giving you advices on the topics to focus your energy on. That you don't enter the hall without knowing those topics. Okay, so in this video, like I said, we are going to be looking at conic sections, and this question was proposed to us by one of our YouTube viewers who commented on a video that we should solve this problem. It means the problem was a little bit challenging. Anyways, you are going to see why the question was a little bit challenging for students who took the examination and even teachers later on. Alright, so let's get started. So here's the equation displayed to you. It has 3 parts. First, we need to show that the equation of the normal to a hyperbola xy equal to 4 at a certain point, which is p 2 on t with t different from 0, is given by t cubed times x minus ty minus 2t to the power 4 plus 2 equal to 0. Now, the second part of the equation is now divided into 2 parts. You read, this normal gets the hyperbola again at a certain point Q. The first part of the second part of the equation says we should find the coordinates of Q, and the second part of the equation says we should prove that the locus of the midpoint of the origin and Q is another hyperbola. Alright, so pay keen attention here and don't lose focus. So let's begin with the first part, which is asking us to show that the equation of the normal to our hyperbola xy equal to 4 at the point P having coordinates 2t, 2 on t with t different from 0 is given by t cubed times x minus ty minus 2t to the power 4 plus 2 equal to 0. Alright, so first we are going to define the equation of the normal. So the equation of the normal at a point is given by, the normal is a line which is perpendicular to the tangent. It's given by y minus 2 on t equal to m into x minus 2t. The point is, let's just say the point is x0, y0. So the x coordinate of the point is 2t and the y coordinate of the point is 2 on t. Now what is m? M is simply negative 1 divided by the gradient at that point. dy by dx means gradient, and then subscript p means that I'm looking for the gradient at that point. So the gradient at that point just gives you the gradient of actually the normal. But since the normal and the tangents are perpendicular, it means that the product of that gradient is negative 1. From there you can make the gradient of the normal the subject of the formula. I get the gradient of the normal to be negative 1 divided by the gradient of the tangents. Alright, now we need to look for dy by dx at a point P. So first of all, we have xy equal to 4. We can carry out implicit differentiation, or we simply divide both sides by x. But anyways, here dividing all through by x, we get the right hand side to be 4x raised to the power negative 1. But it's going to be easy to differentiate. But I use implicit differentiation so that people should also know what implicit differentiation means. Right, implicit differentiation means that I differentiate the equation with respect to a variable, right? So I have xy equal to 4. I differentiate xy and I differentiate 4 with respect to x because I need dy by dx. Now xy is the product of two functions, that's the product of two things, so we need to use what we call the product rule. And to do a product rule, I keep one of them, I differentiate the other, then I add to keeping the other and differentiating the other. So if I keep x, I have the x, and I'll differentiate y with respect to x, I get dy by dx, plus, and I'll keep y, and I'll differentiate x with respect to x, I get 1. Then when I differentiate 4, since it is a constant, I'm going to get 0. Alright, so from here we can subtract both sides by y, and then we divide all through by negative y. So it means our dy by dx will give us negative y divided by x. Alright, so what's my m? My m is negative 1 over dy by dx at p. So let me look for 1 over dy by dx. 1 over dy by dx, I just need to invert this fraction here. So it becomes 1 over negative y over x, which is now negative x over y. But my m is equal to negative 1 over it, right? So I just multiply this left hand side by negative, it gives me m. Multiply the right hand side by negative, I just get x over y. But x is actually 2t because I'm looking for the gradient at that point. The point has coordinates 2t, 2 on t. So x is 2t and y is 2 on t. So x on y becomes 2t divided by 2 on t, which will give me t squared if you simplify correctly. So I've gotten our m, which is negative 1 over the gradient at that point. Now we need to feed back into our equation of the normal, and we get y minus 2 on t to be equal to m is now t squared times x minus 2t. We can multiply all through with t. Multiplying y with t, we get ty. Multiplying 2 with 2 on multiplying 2 on t with t, we just get 2. Multiplying t cubed with t squared with t, we get t cubed, then times x minus 2t. We can now send in t cubed. We get the left hand side to be ty minus 2, the right hand side to be t cubed times x minus 2t cubed times t, which is 2t raised to the power 4. Now we can pull everything on the left hand side to the right hand side, right? And then we simply get what we're supposed to prove. So we add 2 on both sides and we subtract ty on both sides, and we get the equation of the normal. So the first part of the equation, we have succeeded in proving it. Now the second part of the equation is where challenges now come in play, because if you're not a very smart student who is very patient in simplification, you'll give up at the end. But anyways, we are going to see why, if you are not patient in simplification, you're going to give up. Okay, so the second part, we begin with the first part of the second part, that's Roman 1. First of all, it says that the normal, which is the normal we have gotten here, it now gets the hyperbola at a certain point. The point is Q, and the objective of Roman 1 is to find the coordinates of Q. So let's analyze the problem together. Getting me right, so first of all, I give the coordinates of my point Q to be AB. Alright, so the first thing is that the normal gets the hyperbola at Q, right? It therefore means that what? That the point Q satisfies the equation of the hyperbola, and as well it satisfies the equation of the normal, because the point Q is the point of intersection between the normal and the hyperbola. It means it lies on both curves. So the point Q belongs to my hyperbola h, as well as it belongs to my normal. Now you may be doubting what is h. H is my hyperbola, which is xy equals to 4, and n is my normal, which I proved earlier. Now let's analyze together again. Q, if the point Q belongs to the hyperbola, it means that the x and y coordinate of Q satisfies the equation of the hyperbola. Now the x and y coordinate of Q is AB, and the x and y coordinate of the hyperbola is xy. So Q belonging to the hyperbola, it therefore means that AB is equal to 4, meaning you just multiply the x and the y coordinate and equate to 4. Anyways, from there we can get B. B will give us 4 divided by A. Okay, now I can label that equation 1. Next, Q belongs to the normal. It means that the x and y coordinate of Q satisfies the equation of the normal. So the x coordinate of the normal is x and the y coordinate is y. Therefore Q, the x coordinate is A and the y coordinate is B. So Q belonging to the normal, I replace x with A and I replace y with B, and I get AT cubed minus TB minus 2t raised to the power 4 plus 2 be equal to 0. I can label it equation 2. Things now become very, very complicated. How do I find the coordinate of Q? Find the coordinate of Q, I need to find A and I need to find B. So from this equation, right, and I have two equations. So what I'm going to do is that I'm going to replace equation 1 in equation 2, because equation 1 I have b to be 4 on a. Equation 2 I can replace b with 4 on a, and I try to see if I can get a. But definitely, what do we see? We see that a and b are going to be in terms of t, because t can never disappear from this equation here. So replacing equation 1 in equation 2, equation 1 we have at cubed minus tb, but the b is 4 on a, minus 2t raised to the power 4 plus 2 equal to 0. We can multiply this left hand side by a and the right hand side by a. Multiply the left hand side by a, the first term becomes a squared times t cubed. The second term, the a cancels, you just get you get negative 40. That's what we get, negative 40. Now you multiply negative 2t raised to the power 4 with a, you get negative 2a t raised to the power 4. You multiply 2 with a, you get 2a. Now you can pair the terms in a together. I already paired them and I got this. Now what can we verify? What can we see? Sorry, we can see that this identifies a quadratic equation with a being the unknown, because our t is varying, right? Our t is even from 0, yes. So we cannot be looking for t because we need a. But we see that a squared is clear. We have a here, so it's a quadratic equation. Now we can use the formula method. We get a. Things become very, very complicated. Like I said, if you're not patient in simplification, you might give up along the way. So let's simplify keenly. Alright, so a is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. My negative b, this is my b is 2 minus 2t raised to the power 4. So negative b is negative of it, plus or minus the square root of b squared. It means I square b, but from b here I can factor out 2, right? And when you factor out 2 and you're squaring it, you get 4. When you factor out 2 from here, you get the interior becomes 1 minus t raised to the power 4. You also need to square it. Minus, so this is b squared minus 4ac. The 4 is there in the formula. My a is t cubed and my c is negative 4t. Alright, so let's simplify again. This one remains. Now I can factor out 4 from b squared, which is 4 into this, and then 4ac as well. You can factor out 4. If you remove this 4 from here, remember that it is inside a square root. So removing it completely from the square root of the 4 gives us 2. So we get 2 outside. Now the interior, since we factor out 4 from here, we are going to be left with 1 minus t raised to the power 4 all squared. Factoring out 4 from here, we are going to be left with a certain 4, because one of the 4's is going to go away, and negative times negative will give us positive. Alright, now from these two terms, right, we can factor out 2. We factor out 2. Let's first of all send this negative sign inside here. These two interchange position. So negative times negative times 2 is negative 2. Negative times negative 2t raised to the power 4 is 2t raised to the power 4. But since I'm factoring out 2 from the numerator, then you remove 2 from here, you get 1. Remove 2 from here, you get 1. The negative multiplies and the positions of t raised to the power 4 and 1 interchange. So I instead get t raised to the power 4 minus 1. Now we factor out the 2 from here, so we are just left with this square root. Alright, so we can clearly see that the 2 in the numerator here cancels with the 2 in the denominator, and we get this. Now let's try to expand the interior of the square root. Now expanding 1 minus t raised to the power 4 all squared, we get 1 minus 2t raised to the power 4 plus t raised to the power 4 all squared, then plus now this other quantity. Alright, so let's add like terms together. Taking negative 2t raised to the power 4 plus 4t raised to the power 4, we just get 2t raised to the power 4. Now we need to add our 1 to it, and we add our t raised to the power 4 all that squared. Now the interior here is a perfect square, which is t raised to the power 4 plus 1 all squared, because if we expand t raised to the power 4 plus 1 all squared, you're going to get this. Nevertheless, to move from here to here, we can simply complete the square, and the variable here is that's the bunch is t raised to the power 4. Alright, so with that, the square root of t raised to the power 4 all squared is the absolute value of t raised to the power 4 plus 1. Alright, but now t raised to the power 4 plus 1 is already positive, so it means that our a is just t raised to the power 4 minus 1 plus or minus t raised to the power 4 plus 1 all divided by t cubed. So things now are becoming easy. Okay, so a being equal to this, we can separate into two things. Either we take the positive, we get the first, we take the negative, we get the second. Now simplifying the numerator here, we get 2t raised to the power 4. Simplifying the numerator here, we get negative 2. We can divide by we can cancel t raised to the power 4 on t cube is t, but it's a 2 multiplying, and then we have negative 2 over t cube. So those are the two values of a. Now what about b? Our b was 4 divided by a, remember. So it means our b, when a is equal to 2t, we get 4 divided by 2t. And when a is equal to negative 2 on t cube, we get 4 divided by negative 2 on t cube. It means these are the two values of b. So with that, since our cure had coordinates a and b, it means that cure will have coordinates a is 2t and b is 2 on t. For the first case, 2t, 2 on t. And for the second case, a is negative 2 on t cube and b is negative 2t cube. But what do we see? We see that the first coordinate of cure here corresponds to p, so we cannot take it because it was already given. So it means we are going to dive straight away in taking the second coordinate of cure. So our coordinate of cure, which we are asked to find, is simply having the x coordinate as negative 2 on t cube and the y coordinate as negative 2 t cube. Alright, so we have succeeded in solving the first part of the second part of the equation. So let's now go to the second part of the equation. It's asking us to prove that the locus of the midpoint of the origin and cure is another hyperbola. How do we find the midpoint between 2 points? Nevertheless, our cure, we have the coordinates. The origin has coordinates 0, 0. So the midpoint of cure and the origin, we add the x coordinate, we divide by 2. We add the y coordinate, we divide by 2. Simplifying, we get the midpoint to be, the x coordinate is negative 1 on t cube and the y coordinate is negative t cube. So we can define it parametrically as this. So we have the x coordinate to be negative 1 on t cube and the y coordinate to be negative t cube. So a hyperbola, right, we need to multiply the x and y. Multiplying the x and y, it means we should multiply negative 1 on t cube times negative t cube, which will give us 1. So it means our xy is equal to 1 and xy equal to 1 is another hyperbola. Remember that the original hyperbola that was given to us was xy equal to 4. So if we use this coordinates here, which is 2t, 2t comma 2 on t, we are going to get the same hyperbola xy equal to 4. We're actually proving that the midpoint is another hyperbola, right? So clearly we have another hyperbola xy equal to 1. So this is another hyperbola, and we have succeeded in solving all the parts of the equation. So if you love the video, endeavor to like the video, comment if you have an area of difficulty. Yes, so propose questions for us to solve, because we don't want to be solving questions which you will not like. So in the comment section, you can give a question, or you send us a link where we can get the question from, or you send us the question directly to our email address. Like this question, for example, we actually got a clue about solving this problem because one of the YouTube subscribers commented on a video that we should solve the problem, and I believe she's watching the video and his or her problems have been solved. Alright, so thanks for watching and see you in the next video.